Welcome to lesson 52, and in this lesson we're going to talk about the algebraic terms. You're going to see me do three things, and you're going to practice these same skills as part of your criteria for success. 1. Identifying the key components of the expression. That means being able to explain the relationship in words between coefficients and variables. 2. Being able to determine the number of terms in the expression. Can we actually explain it and justify our reasoning? And 3, the fact that we can recognize that terms are separated by plus and minus symbols. There are so many amazing ways that we can describe this number, but let's start with our visual again. So we have 2x plus 5, which really means as a visual, I have some number and the same number again and 5. I have no idea what that number is. I just know I have 2 of them, and then I definitely know I have 5. So here's what we got. We have 2 different terms happening here. Here's term 1, the 2x. This term has a coefficient, that's the number in front, oops, and it has a variable. All that's telling me is how many of the variable I have. I have multiple sets of the variable. I have multiple groups of the variable. And here I have 2 groups of the variable. So that's our first term. And then our second term is our 5. And this is a constant. So I know that this is definitely 5. It doesn't change. I can't substitute it, but I could make these numbers. We can make these 4s, we can make these 7s, we can make these 8s, whatever. They're variables. They can stand for various numbers. They can vary a lot, but this 5 stays constant. So just so we see here, we do have 2 terms, and I'm going to add this in. We have 2 terms. One of them has a constant, one is a coefficient, and a variable. So that's what we got. So let's think about all the different ways that we can really describe these 2 terms. So I'm going to think of just the first way, reading it from left to right. Well, I have 2 x's, or 2 times some number. So 2 times a number plus 5. It's probably the first way you can think about writing this number. So what are some other ways that we can say the plus 5? We could say plus 5. We could say increased by 5. Some people use the term sum. There are all kinds of different combinations. So I could say 2 times a number increased by 5. 2 times a number, or the sum of 2 times a number and 5. Plus 5, adding 5. Okay, these are all different ways. So let's try that other way. 2 times a number increased by 5. How many different ways can you think of those 2 x's? So some people could say 2 times a number, n, or double. Ooh, I like that. Double a number added to 5. Ooh, how about this one? The sum of 5 and twice a number. So you get the idea. Look at all the different ways. These are different combinations of saying 2 different things that are happening. That we have a constant of 5 that's being somehow added to some number, 2 sets of some number. So that's what we have. So let's hit pause. I'm sure you can come up with tons more different ways of looking at this, but let's jot this down so we have it in our notes. And definitely looking at these terms, we're going to use them again and again. This one's nice and easy. We have 8x to the 3rd power, and Clarice thinks that there are 3 terms here. Is she correct? Unfortunately, no, there are not 3 terms, but let's unpack her mistake, because this mistake makes sense in our minds. Why did she think that there were 3 terms? Well, More than likely is because she saw three different things here. She saw an 8, she saw an x, and she saw a 3 at the side. So no, there are not 3 terms. However, there is a coefficient, which was 8, a variable, which was x, and in this case, an exponent, which was R3. So she saw 3 symbols. So there are 3 symbols, but this is not the same as 3 terms. Not the same. All right, so this is actually all together, this does make up 1 term. We have this one here. But that's a very easy mistake. Again, mistakes make sense in our mind when we're trying to develop meaning for this. So it's just something to be aware of. So even though we might see 3 symbols, different numbers, or different variables, it is not the same as a term. They're all connected together. That is what makes this a term. The x to the 3rd power means I know I have x times x times x. And the 8 tells me what? Tells me I have 8 sets of x times x times x. So this is a very complicated, simplified term, but it is still just 1 term with a coefficient, a variable, and an exponent. Hit pause so you can jot this down. Okay, we're going to use our same strategy. We're going to highlight the different terms. So I have 15v. They are 1 term because they're coefficient and a variable. I have another coefficient and variable, 2r. I have a 3rd one, 10v, and I have my constant, 5. So here we have 4 terms. So there are 4 terms. 15b, 2r, 10b, and 5. Okay, so we figured out the terms. Let's look for variables. So we're scanning. I see, here we go. I see a b, an r, and a v. There are 2 types of variables, v and r. And that's important because I know that all the v's are the same number and all the r's are the same number. So there are 2 types. There's v's and there's r's. Even though I can see 3 sets of coefficients and 3 variables, they're really just v's and r's there. So how many coefficients do we have? There are 3. There are 3 coefficients. And you can look for them because they are super friends, our partners. We have one right here, the 15, the 2, and the 10. And it's always easy to see our codes. Like when you have co-teachers in a room, like 2 teachers, the coefficients are just the 2, the variable, and the coefficient, the term in front. They're together, they're next to each other, they're co-partners. So we have that. And do we have any constant? Yes. There is 1 constant. 5. So there you have it. Just jot this down to your notes. In this expression, we have our 4 terms. We have our 2 types of variables, v's and r's, our 3 coefficients, and our 1 constant, 5. And we're going to have a lot more practice using these terms. You're doing some fantastic work now in EE. So let's get some more practice in. And remember to separate it. You can probably recognize that all our terms are usually separated by these different operations, by adding and subtracting operations. But I also want us to remember that when we will do some more work, those operations are going to be really important coming up. And I'll show you a little bit more why in a future lesson. But for now, jot this down to your notes and I will see you in the next lesson, Math Marvels. Take care.